So we're going to look at testing out this bit of code and a small section of our much larger kind of complex sequence that we're looking to test. And we're going to do it through Fluidsim and an OPC UA connection. Okay. Now I've done other videos on this. It's not the easiest thing to set up. So you know, there's a couple of other software and licensing things that you have to get involved with. So there's other videos touching on it. I'm just going to show you that this, you know, is an option for simulating it. Now, as I said, I'm not going to go into a huge amount of detail, but what I did need to do was, now I created a sub-function, so you can look at some of my other videos of how to make a kind of subroutine or a sub-function, and you can go through this, or you could have just included it at the bottom of your code here as well in your main program. But what I had to do is I had to set up a byte, so that's 8 bits. So that could store 8 kind of outputs. So if I just look at the Fluidsim, pretty much what's happened is you get a Fluidsim block and it comes in a byte, so it's got 8 bits, and so that's why I have to send information over in a byte. You have to do it 8 bits at a time. So I've set up them an EBO byte and an ABO byte, and as I said, all I'm doing is just transferring the little bits as they match up. So you see BO should be EBO.3. So if you look over here, there's EBO, there's number 3, and there is B0. So you're just matching them up to your wiring diagram. As I said, there's other videos on this, so I'm not going to get into it too much. But just basically that you know that you can set up the OPC server, make sure you got your symbol configuration done and that it's built. Make sure that you call, if you're using a subroutine, make sure that you call it in your main function. So drop in a new network and call your POs, your subroutines, drag that in, just save it as an instance. Sorry, I have to do that again. Drag that in, make sure it saves as an instant, and yeah, just make sure everything's built up nicely. Okay. So as I said, there is videos on this. I'm not going to get into too much. I just want to see it simulating. So if we log in, so we're logging into a virtual PLC. So again, that's another bit of software that comes with Codesys, that you're logging into this virtual PLC. Okay. Then what we're going to do is we'll press play. So press play on our simulation. You'll see, you know, nothing's happening. Everything's false. We go in here and make sure this is set up for OPC communication, looking for the correct bits of the application. So make sure you've set this up. Again, I have videos on it, so make sure it's in OPC mode, and it's looking for the correct bytes. So press play in the simulation. So you'll see these two are starting in their attracted position. Then yeah, make sure that you've pressed play here, and you'll be able to literally press play. You'll see there's the 2 LEDs came on. This starts going through the sequence, so I can check, is that sequence correct? You'll also see if you go into Codesys, you know, this all happened live. I can see I'm going through my steps there. Step 100, step 100, and oh, looks like it skipped maybe 110, 120. Maybe that just happened so quick in terms of turning off the lights. So we'll double check it. I just have to reset our code here. So do a reset warm, pops the CO back down to 0, resets everything. So if we press play, so remember what's the sequence we're looking to happen. So the 2 LEDs come on, then A goes forward, B goes forward and back, then A comes back, and then we repeat that, and then C comes off, and then we wait 1 second, we go into the next sequence. Okay, so we'll try and see that happening. So press start, 2 lights come on, then A goes forward, B goes forward, B comes back, then A should come back, then A should go forward, B should go forward and back, then A should come back, then we should see C come off. There'll be a 1 second delay, and then we'll go and do the next sort of routine. So you can see I can simulate this once you know you've built the electro-pneumatic circuit, put in the PLC, done the OPC communication, and set that up between Codesys and Fluidsim. You can simulate it really nicely, to be honest. Very lovely presentation of it. But as I said, it's not that easy to set up sort of the licenses agreements and the communication between the two bits of software, but it is possible. As I said, check out the other videos if you want to see how to do that. So that's one way of testing it. Now, look, that seemed to run pretty smoothly. It seems to do everything that I was looking for it to do. As I said, if it did break down, you could use, you could see what point in your code did it break down at, and then you could go and look at that line of code and see what happened, where it went wrong. So that's the benefit of these number things again as well. But it seemed to move quite smoothly through the whole scenario. And if you want to just see this timer happening, I'll do it again. Well, reset warm, get everything back down to 0, press play here, turn this on, and what you'll see is you'll just see it moving through the code. Step 60, step 70, so you're seeing these bits move. Eventually get down to here, move through, see the timer start to time. Now, I don't know if that just happened super quick, or did we actually see the timer timing. Yeah, so I did just check back, and it does time. It's just only a second, so it happens pretty quickly. But like I said, you could use those step numbers, see where it broke down, check do you have the right inputs triggering, or have you the right step numbers triggering the right outputs at those scenarios. So that's one way of testing it. We'll look at another way of using the kind of inbuilt visualization within CodeAssist itself. Pretty much if we were developing a HMI screen, we'd do something very similar, and we can use that as a simulation to test for it as well. So we'll look at that in the next video.